Now we're on to exercise number 3, longitudinal waves. So what I've done before is send transverse waves down. Transverse means a 90-degree angle to the direction of motion. The wave travels to the table and then back to me. The amplitude, though, is sideways, whereas the wave itself, the energy moves to the table and comes back. So it's along the slinky. The amplitude is transverse. Longitudinal waves are along the direction of motion. So these are a little bit harder to visualize, but it's pretty easy with the slinky. You guys see that? It's another type of wave. It goes to and from. To and from. So longitudinal waves are along the direction of motion. In fact, I can make a standing wave if I want. It's a little harder to make a standing wave, but let's see. There you go. There's a standing wave. It's much easier to do standing waves than transverse. You can see it a little better, but it doesn't mean it doesn't happen longitudinally. In fact, all musical instruments inside of them use longitudinal waves to produce resonance conditions. So now that you know what a longitudinal wave is, let's see if we can estimate which one is faster, longitudinal or transverse. Now this is a little hard to notice, but let's do a transverse. We maybe can like tap our foot or something. 1, 2, 3. All right, let's see the longitudinal waves. 1, 2, oops. 1, 2, oh, I don't get to 3 on that one. It looks like the longitudinal waves are a wee bit faster. Let's try this again. 1, 2, 3. So I'm counting the time it takes to go down and back to my hand. You can't really see my hand, but so again, let's do the longitudinal waves. 1, 2, 3. Okay, so it's about 2.5. So it looks like the longitudinal waves are a wee bit faster. And if we had done a more qualitative analysis of this, we would have found that out. And this is the basis of how scientists figure out where earthquakes come from, or where the epicenter of earthquakes are. They know the longitudinal waves travel faster through the Earth's crust than the transverse waves do. That's a fact. And they know exactly the ratio of the difference in speed. So when an earthquake happens, the P waves and the S waves, the P waves are the primary, those are the longitudinal waves, they go out and they hit the stations first. The transverse waves, or the S waves, hit after that. And what they do is they look at the time between the onset of the longitudinal waves and the transverse waves. And they can figure out how far away the earthquake is from their position. Now, the last part of this exercise is to look at longitudinal waves. And I tied a piece of string to one of the legs. Let me just see if I can move it up like this. You can see it. There it is. I gotta move the slinky, so there it is. All right. So this is. Let me actually just do it in a separate video, so I can set it up better.